a 5-volt battery with internal resistance 2 ohms and a 2-volt battery with internal resistance 1 ohm are connected to a 10 ohm resistor as shown in the figure. Right, this is basically the figure where positive terminal of the 5-volt battery is upwards and positive terminal of 2-volt battery is downwards, and this is the 10 ohm resistance. What will be the current in the 10 ohm resistor? Right, so this is a very simple basic question of Kirchhoff's law. What we do in this, we can do it by a number of methods. What we do is I'll use the loop rule. Basically what I'll do is I'll consider them two loops. One is this and the second is this. Right, now in this loop I'll consider that I1 current is flowing, and in this loop I'm considering that I2 current is flowing. So what will be the net current in this resistor? It will be I1 minus I2, let us suppose. Right, now let us draw the equations, write down the equations. In loop 1, what will happen? 5 will be equal to 10 into I1 minus I2 plus 2 into I1, right? And so we can basically just see this equation. We can calculate this equation, 10 I1 minus 10 I2, right? So mark it as second equation. Let us see. Right, now in loop 2 2 will be equal to 10 into minus 10 into I1 minus I2, because we are assuming that current is flowing in the downward direction, and so this is opposite to the loop that we have considered, so it will come out to be negative. This is basically the sign convention. You might have a different sign convention used, but we use in Zion tutorials, we use this kind of sign convention. If you are following the Zion tutorials booklet, you will be seeing this convention, right? So plus I2, right, because the internal resistance is of 1 ohm, so 1 into I2. So this is the third equation, and if we just calculate it, it will come out to be minus 10 I1 plus 11 I2, right? Let us mark this as fourth equation. Now from second and fourth equation, what we have to do, we have to eliminate one thing, right? So what I do is I'll multiply the second equation by, let's say, 5, and I'll multiply this by 6. So what will happen, and I'll add them, what will happen? I1 will get eliminated, right? So let us do this. If I'm multiplying it by 5, so the net equation will be, equation second will be 25 will be equal to 60 I1 minus 50 I2, right? And the fourth equation will be 12 will be equal to minus 60 I1 plus 66 I2, right? So if we add them, what will be the net equation? They will cancel out. So this will be, if we add them, 37 will be equal to 16 I2, right? It implies I2 will be equal to 37 by 16, right? Now if we see what we have to calculate, we have to calculate the current in the 10 ohm resistor, which will be what? I1 minus I2. Generally what the students will do, they will put this thing in second or fourth equation, and they'll calculate the value of I1, which if you calculate the value of I1 and then you have to subtract from I1 minus I2, which will be a little lengthy process. Rather than that, what you do is put the value of I2 in the third equation, right? So you will directly get the value of I1 minus I2. Let's see how. So it will be 2 will be equal to minus 10 I1 minus I2, right, plus 37 by 16. So it implies you will get 10 into I1 minus I2. This will be 37 by 16 minus 2. So this will be equal to what? 32, 5 by 16, right? So it implies I1 minus I2 will come out to be 1 by 32. So which will be nearly equal to 0.03, and the direction we have assumed, which is from P2 to P1, this current is coming out to be positive. That means the current will be flowing from P2 to P1 and the value will be 0.03. So that means option C will be correct.